Hello. Today we're going to talk about topic 2, section 5 and 6, modeling with quadratics. Okay, so let's start with the basics. You have three types of quadratic functions. Okay, you have it in, the first one is standard form, then you have vertex form, and then you have factored form. All right, and whenever you're asked to sketch the graph, you're looking for these things: the overall shape, the X and Y intercepts, okay, label the coordinates of the vertex, and your axis of symmetry. Okay, so Cognitive goes through all the basics. So this is all your general facts of standard form. Okay, so if you forgot any of that, write it down. This tells you a lot of good info. Then you have quadratic functions in vertex form. So here it's a lot easier to see everything because you get H and K, which is your vertex. You can, A always tells you what it looks like, whether it goes up or down. It's just, yeah, it's the most useful form in my opinion. Right, you also have factored form. So factored form is nice because this gives you your X-intercepts. Okay, so remember, whenever you're finding your X-intercepts, you're setting this equation equal to 0. So that would be when X minus P is 0 and when X minus Q. So here, P and Q would be roots, or zeros, or solutions. These all mean the same thing. Right, solution, zeros, roots. Okay, also deals with X-intercepts. Honestly, I wouldn't worry about knowing all these connections, right? P plus Q over 2. Yeah, I wouldn't, because if you just FOIL that out, you'll get it in standard form. So I always recognize standard form and vertex form. Okay, so that's how you can manipulate things. Alright, so the first example, we want to sketch it, so we get out our calculator. Alright, then we're going to plug in x squared minus 4x, then hit graph. Alright, so let's find our x-intercepts. That would be the first thing I'd want to find, so we do second trace. And we can find the zeros, so number 2. So you hit the left side, right side, your guess. Oh, well, I kind of told you, 0, 0. All right, and I'm going to go out on a limb and see what happens when I trace 4. Okay, I lucked out. I got an exact answer. So my x-intercepts are 0 and 4. Okay, then I can find my minimum here. So do second trace, go to number 3, go to the left side, go to the right side, and your guess. And here I get 2, negative 4. Alright, so now I know those values. I can go ahead and sketch it. And all I'm looking for is these things. You don't have to put any other tick marks. You don't have to put anything else. You just want your X and Y axis. And then draw it through your X-intercepts and then label everything. So here we have our function. Our axis of symmetry is always dotted. It's a vertical line that goes through my vertex. That is why it's x equals 2, because it goes through 2, negative 4. So it's a vertical line that goes through that point. And here are our x-intercepts. Remember we said they were 0 and 4. Okay, and now we want to state the domain and range. Now, again, Cognitive doesn't do a very good job with this part too, guys. I would put arrows on these. We know that equation goes on, or that function goes on forever. So for our domain, all right, we know that we're looking at our x-axis. So left and right, well, I know x can keep going to the left and it keeps going to the right, so it's always going to be all real numbers. And you can put that in, let's see, interval notation would be pretty easy, negative infinity to infinity, or just state all real numbers. Then your range, let me do that in a different color. So here your range, you're looking at your y's. Ooh, my line was a little off there, and it's still a little off. What am I doing? I'm just tracing my screen. Okay, that wasn't my fault. Anyway, so here you're looking at your y's. So how high and how low the graph is. Well, the graph keeps continuing to go up, right, towards infinity. Right? Those arrows are going towards infinity. But down here, the graph stops. It doesn't get any lower than -4. It's as low as it goes. So we read it from smallest to greatest, smallest to greatest. So we go from -4 to infinity. We put a bracket around -4 because we were actually at -4. All right, we actually got down that low. But we did not get to infinity, right? You don't go to infinity and go, oh, I made it. All right, so you put parentheses around it. Okay, so for this one, all right, since you know it goes through these points, well, I would go ahead and plug those in. So for example, this is an x and a y. So 8 would equal a times -2 squared plus b times -2. Plus c. So we get 8 equals 4a minus 2b plus c. Then we get this x and this y. So we get -4 equals, well, a times 0 squared plus b times 0 plus c. So that's great because we automatically get to know -4 is c. So we know we can replace that c right there. Okay, so we get a new equation here. So 8 equals 4a minus 2b minus 4. So if I just go ahead and combine those together, I get 12 equals 4a minus 2b. Okay, so you're probably thinking, well, great, that's one equation with two variables. I can't really get anywhere. Well, not quite. Let's think about it. I'm a visual person, so let's look at the graph. That always helps. So, the thing I want to point out is the axis of symmetry is x equals 1/2. So, at 1/2, there, all right, is my reflection. Okay, so for the point 0, -4, we are here. So that means I'm going to have another point the same distance away over here. Well, if I go from x is 0 to x is 1/2, then the next point has to be at 1, right? Equal distance. So if this is at 0, -4, then this point is at 1, -4. Well, now I have another point. So let's plug that point into our equation. So I get -4 equals a times, 1 squared plus b times 1. All right, plus c, but we know c is -4. So we got -4 equals a plus b minus 4. Move the 4 over. Okay, now I've got two equations with two variables. So you use your poly simulation app and you get 2 for a, -2 for b, and we already know C is -4. Okay, so let's go on to the next one. So we have the vertex, and it passes through the point -2, -1. So find it in vertex form. Well, that's not so bad, because vertex form, oh, maybe it might help if I'm actually using the pen. So let's start. We know vertex form is this. Hopefully you have this memorized, because that's the transformation form for every type of equation. If you know A, H, and K, and you can name the transformations, you got everything. So here, we're going to put it in vertex, so that's our H and that's our K. So we get y equals a x minus 2 squared plus 3. Well, I got too many variables. I still don't know what a is. But I also know it goes through this point. So that's going to be an x and a y to help me figure out what a is. So I'm going to go ahead and move that 3 over, so make that -4. And so then we get a times, well, -2 minus 2 is -4. -4 squared is 16. So a is -4 over 16, which is -1/4. So the equation in vertex form is -1/4 parentheses x minus 2 squared plus 3. So express it in standard form. So what I would do is I would just FOIL everything out. Okay? So I don't like that it has a fraction, so I'm going to go ahead and multiply each side by 4. So I'll get 4y equals -1 x minus 2 squared plus 12. Then I'm going to FOIL that. I already combined my like terms. Okay, then I get 4y equals -x squared plus 4x minus 4, but plus 12 is plus 8. So then I get -1/4 x squared plus 1x plus 2. And divided by 4, and there's my standard form. Right, then we want to find the y-intercept using standard form. Well, the y-intercept is when it hits the y-axis, so that's when x must be 0. So if x is 0, we get y equals 0 plus 0 plus 2. So it's always that last one, that constant. So the y-intercept would be 0, 2. You always write it as a point, unless otherwise stated. And the last part is doing a nice little sketch. And, oh, my thing didn't grab. Oh, there we go. It's just slow. Okay. Ooh. Computer, I guess, got a little overloaded. All right, so here is your graph. Again, I'm not worried about having all these tick marks down, up and down the x and y axis, so don't worry about those, but make sure that these points are labeled and, you know, relatively where they should be. You know, don't graph 0, 2 here and then put 2, 3 here. Right, that doesn't make sense. All right, so make sure it looks appropriate. Okay, but I don't need it to be exact with tick marks. So here we want to write the equation in vertex form by completing the square. Honestly, I've taught completing the square over and over again, and it's difficult. I would graph it and find the max or minimum to get your vertex, so that way you can find what h and k is. Or equation-wise, right, if you want to be more exact, all right, if you've got it in standard form with ax squared plus bx plus c, right, y equals all that, the h value is always -b over 2a. So in this case, it's going to be negative 4 over 2 times 1, because A is 1, B is 4, C is 5. So our H value in this case is just negative 2. And to find the Y value, well, the K, that's just their Y value. So to get K, that's just like finding Y when you plug negative 2 in. So you get negative 2 squared plus 4 times negative 2 plus 5. So we're going to get 4 minus 8 plus 5. So we should get 1 for K. So our vertex is going to be I lost my H. Okay, x plus 2, because minus a negative, squared plus 1. That is vertex form. So then we state the coordinates of the vertex, and we can sketch it. Okay? Alright, so for this one, let's start with the X-Intercepts. So, let's see. The X-intercept is when y is 0, so that means that this equation must equal 0. So since it's already in factored form, this is great, because I can easily find what x is. So my X-intercepts are going to be negative 1, 0, and 2, 0. Then my Y-intercepts, or I guess Y-intercept, I'm only going to have one of those if it's a function, is when x is 0. So I get y equals 2 times 0 plus 1, 0 minus 2. So we get 2 times 1 times negative 2. So y equals negative 4. So my Y-intercept is going to be 0, negative 4. Always write it as a point unless otherwise stated. So then we can find the vertex. I would not follow that crazy formula that they had in Cognity. What I would do is I would either use my graphing calculator and put that in there and then find the minimum or maximum, right? Or let's see, it's another way. You could FOIL it out and do standard form and then do the negative b over 2a. Oh, I got it. The easiest way. So here, if we visualize it, I should have done this in the first place. All right, if we graph our X-intercepts, we get negative 1, 0, and we get 2, 0. Well, then you have your Y-intercept at 0, negative 4. That's not as important, okay? But what is important, okay, well, here, I'll put it down there anyway. All right, what is important is remembering that this graph is symmetrical. So if I have a point here, and I have a point here, then I best have my axis of symmetry right in the middle. Okay, that's probably, yep, that is exactly what their silly equation is doing. Yep, I'm looking at it Cognity right now. They wrote it in some fancy technical way, but that's this way. So since the axis of symmetry is cutting it right in half, I know the vertex has to be along there, because the vertex is your folding point. Okay, so because think about it, I want my graph to do this. And I want it to be symmetrical, so it needs to be cut in half through that. So I know for the vertex, H must be at 1/2. So if H is 1/2, I can plug it in to get my Y, or my K. So 2 times, well, 1/2 plus 1 is, well, 1.5. And then 0.5 minus 2. Just easier to think in decimal sometimes, you know? All right, so then we can FOIL that out. Ooh, now it's not so much fun, but that's okay. We've got calculators. So let's see, 3, I obviously don't have one right in front of me. 4.5, I believe. Okay, so your vertex should be at 1/2, comma, negative 4.5. I don't care if it's decimal or fraction as long as it's exact, right? If you can't get exact, then obviously you can round. All right, so big reveal. Let's hope I'm right. Woohoo! Yeah. Okay, so there's our solution. I hope that makes sense. Well, let me know if it doesn't. And let's try another problem. Okay, so now we've got a word problem. All right, so just think about what you have and try to put into an equation. All right, so what I mean by that is it's enclosed with 100 meters of fence. So we've got all of this has to be a fence, including this line down the middle. So if we add up all the sections, we should have 3 x's plus 2 y's, because y is your length down here, and that should all equal 100. All right, now we want to express that length, all right, of the 2 rectangular fields in terms of the width. So we want y in terms of x. So get the y by itself. So we move the x over. But then I wrote x, being silly. I don't know. Sorry, little pen malfunction there. All right, so then we get negative 3x plus 100, or 100 minus 3x if that's easier. I know, probably a lot of you actually wrote it that way, so that's fine. So you get y equals this. So that's the first one it asked for. So then it says, write a function that models the total area of the fields in terms of the width. So the area, we know that is just length times width. So x times y. So we want to write it as a function, so in terms of x. So we know we have an x here, and we can replace this y with this y. So now we wrote the area in terms of x, a of x. What? That's where it comes from. So a of x equals length times width. So that's our function. All right, and of course we can write it out nicer than that, like as a polynomial. So a of x equals, well here, if you want to divide that 2 out, and let's see, I'm going to go ahead and write that as a decimal because I know y'all are going to do it. As long as it's an exact decimal, that's fine. If not, leave it as a fraction. Okay. Let's see, minus 1.5x squared. Okay, so then we can write it in descending order if we wanted to. Okay, so that's in standard form. Okay, our standard form of our parabola. So determine the value of the width, x, that results in the maximum area. So the biggest a value, so we need to figure out, because think about this is a negative a, so we know it's like going like this. So the a of x represents y. We want the highest y, which is our vertex. So C is just asking for the vertex. Think of that. So you do h is going to be negative b over 2a. Got to have that one memorized. So negative 50 over 2 times negative 1.5. Alright, so when you work that out, you end up with, let's see, 50 over 3. So that's the value of x that results in the maximum value. And here we want to find that actual area, so now I would plug it into your calculator. So I would, made that a little too large. Okay, so we're plugging in 50 over 3 into our equation. So we're plugging it in here. So negative 1.5 times, I want to put in parentheses 50 divided by 3. Then I'm going to square that number. And I'm going to add 50 times 50 divided by 3. And I get 416.6 repeating. If I want to put it as a fraction, I hit Math, Fraction, Enter. So I get 1250 over 3, which is my answer. So if I can get it as an exact answer, do so. Okay, so for this example, we're going to learn how to use our calculator to model the quadratic function. So here you go to your stat list, edit your lists, alright, and type in your time and your height. So pause it and do that. Okay, so there I graphed it. So now I'm going to clear my equations and turn on my stat plots. So turn that one on, go down, turn on your scatter plot. List 1 was my x's, because that list 1 has to be my time. List 2 was my height, so that represents my y value. So then I'm going to do zoom number 9, stat plot, zoom stat, so I can see it. And yes, that looks like a quadratic. It looks like it's starting to do that curve. So yes, I would say a quadratic model is appropriate. So now let's find a function that fits the data. So now to get the equation, hit clear and go to stat, go to calc, so scroll over and hit calc. Then we're going to go to quadratic regression, so number 5. Hit list 1 is my x's, list 2 is my y's, calculate. So now here I've got my A, B, and C. Alright, so now I just write that out into 3 sig figs. Okay, so here's your equation in standard form. And now you want to estimate at what time the ball hits the ground. So if it's hitting the ground, then that means the height must be 0. So what you would do for part C here is you would set this equal to 0 and solve. Alright, so you should get 2 answers. Alright, and you think about which one makes the most sense. What I mean by that is you probably get a negative answer, or negative x value. That doesn't make sense, because remember x is time, y is your height, so time should not be negative, neither should height. So your x value ends up being, I think, 9.66 seconds. Okay, so that's how long it takes for the ball to hit the ground. Alright, so that's the basics for quadratics and applying them to word problems. Let's see, if you have questions, just talk to me in class. Okay? I promise, it's a lot easier than it sounds.